Okay. Jeff, let's roll. All right. Welcome to our second major panel discussion of IBC 2019. And this is, again, a very distinguished group led by Thomas Bause-Mason. And I'll let him introduce all of the individual speakers. But the session topic really is control. How do we keep control of this IP transition? And you've got some real experts here, some people with a lot of real-world experience, and really looking forward to this. So take it away, Thomas.
Yeah, thank you. So this session is really about real-life implementations of SMPTE ST 2110, ST 2059, AMWA, and we have a good panel here who have a lot of experience with implementing these standards and specifications. And we just want to find out, what's happening. Is it real? Is it really happening? And what are the issues we found? What role does AMWNMOS play? What else do we have to think about in terms of security? What's with the move into the data center? And we have here Brett Gilmer. He's the executive director of AMWA. You're also consultant, Gilmer and Associates, right?
That's correct.
We have Karl Paulsen, who is the chief technology officer of Diversified. And then we have Felix, and you have a longer title. He's the director of engineering lab services, architecture, and strategic development at CBC in Canada, Radio Canada, and they're building a new facility, so it's going to be interesting to get an update on this. And so maybe let's get started with, what are you doing? What's your experience? What projects are you working on? And maybe we start with you, Felix, and you tell us all about what's happening in Canada, and then we go along. And
Yeah, so as you said, we're in the process of building a new facility. It's our headquarters in Montreal for the French services. So that's a major facility, which is a full news production, TV studio, radio, online. So it's like 8,000 employee place. So it will be done all IP, all 2110, using the state-of-the-art technology about this. So we're really in that moment where the technology is available to be able to do that, but the technology is very early. So we experience also all the gaps and the limitation at the time, and working very hard with the industry to address all of those gaps.
Yeah, and I think you substantially shrunk your facility, right? And isn't that?
That's one of the main driver for going IP. Is the current facility is about a third of what we used to have, so it's very more condensed. From 550 racks of equipment, we go down to 150 racks of equipment to cover a similar functionality. Yeah. So the space constraint at some point was only possible doing IP.
Yeah. Karl, I know you told me beforehand that you were involved in at least 10 projects involving ST 2110, and you couldn't give me any specifics, but maybe you can tell us a little bit of what Diversified.
I think at the time I told you we didn't know ourselves how many we really had, but since probably 2017, we've either have completed or have in progress right now 42 major facilities that we've built 2110 and 2022 systems in a very short period of time. Some of the projects we've got underway now are quite large, quite major, and have completion dates that are out into 2020 and 2021 and even beyond. So facilities that are looking at making the transition, or in some cases are making it incrementally. They're building a new bridge over the top of everything that's SDI, because that's all they can do right now from either a budget or a space standpoint, all the way to brand new greenfield facilities.
Brett, you're a major force in development of standards and specification, but you're also involved in deployment of those standards, I take it. And what's your experience? What did you do in that area? Is there any specific project you can talk about? Or?
Sure. What I can say is somewhat limited by NDA, but as much as I can, I'll talk about it. I'm involved as a strategic technical consultant with Gordon Castle and the guys at Eurosport They're in the midst of a major project that affects 3 different physical locations through Europe, London, Paris, and actually not far from here at Hilversum. And again, it's a 2110-based facility, live sports all the time, one of the biggest live sports broadcasters in the world, and some fairly significant pressure to get on the air for a few small events that they have the entire rights for all of Europe for. So I'll do my best to answer what I can. I want to be clear, I'm not an employee of Eurosport. Gordon did make a presentation here at the IP Showcase, though, and people could look that up along with this presentation in the future and hear from Gordon directly. And I would suggest that if people are interested in more details about Eurosport, that they look at that as well.
Yeah. Looking at a technology adoption curve, I think we're still kind of like in the early adopter phase of ST2110. Maybe at the end of it, do you think the ST2110, pure native ST2110, ST2059, AMWNMOS infrastructure is realistic and can be built, or what's your opinion? Maybe Felix?
Yeah, I mean, otherwise we would not do it. So yes, 2110 is a technology that will enable the transition to IP, but 2110 alone is not enough. So what we need is a full stack of technology comprised of ST2110, PTP, and 2059, and then we need also a number of functionality on the control layer, and I guess we'll talk a bit further about this. But that's a very important point that with 2110 we have the transport layer, right? But it's not enough to really achieve what we need. So what we really need is a full stack. So I have here the famous pyramid from EBU, and it lists a little bit what we wish to have in a complete system.
Yeah.
And we need to address the control, the configuration monitoring, and also the security. And this is a multiple. This is an ensemble of technology that will enable us really to do those new IP-based facilities.
Yeah. Karl or Brad, any input? What are the issues when you implement ST2110? We heard some of the issues.
Yeah, at least in the facilities that we've been involved in, I would say no 2 facilities have turned out the same, because the technology and the completion and the augmentation of the standards is an ongoing process. We're in first year review of several parts of the original 2110 stack that was discussed here or released here in 2018, and there's not going to be significant changes, but there's little tweaks here and there that we have just found as a result of implementation, both from the integration side, the end user requests and needs side, and the manufacturer sides continuing to evolve their own products and so forth. So this is not unlike what happened with SDI 35 to 38 years ago when it started. We didn't have everything in place at the first, but there's certainly significant elements of this ready, willing, and able to be produced and operate, and we've so proven that in many, many facilities. Most of if you go to a major stadium or a major arena for sports, at least in the U.S., probably 75% of them that have been built in the last 2 or 3 years are all 2110 or 2022 or something of that equivalent. So you're really watching live IP going on.
From my perspective, I've been involved in this project. I've visited 4 broadcasters that are involved in IP projects over the last month. And the consensus seems to be that a 2110 plant with PTP timing can be built. It works. That there is a pretty big body of expertise that people have to have, or they have to get from somebody like Karl or other companies in order to make things work. The control and other functions that Felix alluded to earlier are a critical part of that, and so anyone who is doing these implementations, for real, they're building complete systems. And so standards and AMWA specifications will play a part in that. But then there's a number of other things that they're going to have to do in order to build complete systems that actually go beyond the pyramid. And so I've been saying that to really build operational systems, you need a JTNM TR1001 plus sort of functionality. And some of that will be things that are built out of technologies that the IT industry already has available. And to the greatest extent possible, for example, in managing configurations on an ongoing basis, which is a hot topic right now within Eurosport, we're specifically looking at how do we add functionality from the IT world to augment the sorts of things that are already being discussed in the standards bodies. And I think that's the reality of where we are now for anyone who's doing an implementation, is that they can pick up 2110, they can pick up PTP, they can pick up NMOS, and then they're going to have to add other things as well. And I think the industry is working out right now the best ways to use DNS, DHCP, LLDP, maybe some of the continuous integration tools like CBC is doing some work with Ansible and so on. How do we pick up these tools from the IT world, combine them with the standards that allow us to do the special things we need to do in order to do a media facility, and make that into a complete system? And from where I sit, one of the biggest challenges that many people are facing right now is how do they develop a coherent system architecture view that lets them get on the air now with what is available, that then allows them to evolve to what they aspire the facilities to be, and to really unlock the full potential and promise of IT, not necessarily IP, but IT. And I think it's very difficult for a lot of organizations to find enough time to think at that strategic level whilst also working out a number of fine-grained technical details.
Yeah. Okay. Yeah, you're deeply involved in the creation of JTNM. Actually, you all are, right? So in the JTNM Tier 1001 -1, which I assume implicates there are going to be more parts, right? Do you have any perception of what these other parts could be? How much of the JTNM Tier 1, or how much of an IP infrastructure is covered by TR 1001-1? And can you put a number against that? Is it like 50%, or at least Tier 1001 should enable you to build a functional ecosystem, IP ecosystem, right?
Well, maybe somebody else wants to speak up here. Briefly, I'll just say that the problem, and it was very helpful to quickly develop this document we're talking about, JTNM TR 1001-1. It was easy to develop it because there was a specific problem we were trying to hit on the head. And that problem was, how can we make it easy to take a piece of equipment out of a box, put it in a rack, connect it, have some minimum human interaction, and then have that device become available in a media network.
Yeah.
So it had a very targeted problem that we were trying to solve, and I think it does that quite well. And we still need to see more adoption around that, which is, I think you'll hear that as a drumbeat on and on. But there are other problems, and where -2 or whatever might go in the future is yet to be determined. We have had active discussions here at IBC about what might we do next. But as an example, a number of people who are building these facilities may use spreadsheets that turn out to be pretty massive spreadsheets to describe the initial system configuration, and whether you're building the system internally or an integrator like Diversified is building that, it's very important to identify a number of different parameters per sender, per receiver, not just per device, but per basically video stream, audio stream, and so on. These sheets end up becoming very detailed, and that may be a very good tool in order to get up and running with a facility.
Yeah.
But in a situation like the Eurosport situation, that configuration may change on a per season basis or even on a per game basis, depending on what it is. And a spreadsheet is not really enough to do dynamic system configuration on the fly. And so, and it's also very brittle, honestly. It's, I'm have just started some discussions with Felix about this. They've got a potential solution that he might want to talk about. But this is an example of some of the things that we're talking about for the future.
Yeah. Felix, I mean, how helpful was JDM TR 1001 in your build? I mean, was it something you relied on?
That's a requirement. That's what we ask. So this addresses the top of the pyramid, basically the top 3 layers, down to this connection management and control and discovery that is just a common denominator for a system that at least all the devices speak the same language. And on top of it, you will have proprietary protocols to have defined control of everything. But at least you have a common denominator. I think TR 1001 delivered that, and it gives a direction for the industry that we go to adopt IT technology like DHCP, DNS, LLDP that are already out there in use, and it's nothing new, but it's just a direction for the industry that this is where we want to go. The move to IP, the benefit will be gained when we get to the IT foundations of that transition. Now, what we need to do next in terms of getting a consensus across the industry, because TR 1001, I call it a consensus because it's now adopted in AIM's roadmap. You see here a number of vendors have already passed the JTNM badge program on TR 1001. There will be, I guess, this continuous program that will continue in the future. So for me, the boat has left in terms of TR 1001, just a question of time that the implementation are there. What's coming next, if we are going to do a -2 or something else to complement that, I guess it's to go further down the pyramid, which is this whole question of monitoring and control and configuration. And is there a way to get a consensus for a single API for configuration of all equipment? Maybe it's hard, but is it possible to at least agree that the APIs of the different devices are open and therefore are published, documented, and can be integrated? And then that enable us, the users, to use IT methodologies like continuous deployment and DevOps that's already used. Again, we don't invent anything. So that Ansible approach is just to use an IT continuous deployment tool and to add some module for open API of devices. And once you have this, you remove a lot of that spreadsheet operation of manually entry of thousands of parameters that is maybe possible on day one when you start your plan. You spend a lot of time configuring everything and everything is perfect. But in the daily operation, what happens when you do a change in your system? It's so easy to break. There's so many parameters. So you need to keep track of that. You need to be able to roll back if you do a mistake. You need to be able to have a methodology approach when you do firmware update, and firmware and software update is something that will become even more often than what we used to do with our hardware bugs, where when it works, you don't fix it. It's working, you don't touch anything. Now in the future, software upgrade will be a regular thing we need to do. So we need to adapt those kind of methodology. So it's really about having a common understanding in the industry about those questions, so we can do large-scale implementations.
So one of the solutions and one of the value propositions that came out of both last year's JT&M tested and the badging this time, as well as TR 1001, is being adopted and accepted by industry, particularly new users. They are finding that it's of great value to build a sandbox in their own facility, particularly if they're going to build a new facility or expand and migrate, that allows them to test and evaluate both their own personal understanding of the systems and the technology and so forth, but to evaluate and test other pieces of equipment. And we found that in probably the last 4 or 5 systems that we've been putting together. The end users, as soon as they know they've got the go button on the project, have built up a small networking structure. They've got test generators, they've got monitoring gear, and then they literally invite key manufacturers in to bring their kit in and test and evaluate it and learn. And they've been using the guidelines from the badging processes and the testing processes, as well as the as far down the stack in the pyramid they could go with TR 1001-1, and using that as an evaluation criteria to accept or reject equipment. So it behooves manufacturers to step up to this plate very quickly, and they are. It's very obvious.
You're talking about the JDM Tested Program. Maybe for the audience, for the people who don't know what JDM Tested is, can you give an explanation what it does and how it's done, how the certification process works, and
Me? Okay.
Well, we've all been through it.
That's true.
JTNM.
Yeah, so the notion behind the tested program is that there's a published test plan that anyone can run. This is the first thing. So just because EBU and IRT have actually been executing the test plan doesn't mean that they're the only ones that do it. We started out from the beginning with the intent that users and manufacturers could test whatever they wanted. And the goal was to determine the level of compliance with the SMPTE standards and the AMWA specifications. This sounds easy. It actually requires a lot of hard work and industry agreement around how you would test these things. But in the end, we have now a couple of times done testing where there is a published test plan that's available publicly at jtnm.org, and anyone can download that plan, and step by step it tells you what we did at private, well, they weren't private events, at industry events. People got together either at Fox in the Woodlands, I guess now it's Disney Woodlands, but anyway, we got lots of people there, over 100 people there, racks of equipment, and ran testing against 2110 implementations. Last month, we did the same thing in Wuppertal. The guys at Riedel were kind enough to host us there, and we did testing of 2110, but we also added another test program which included a test plan for NMOS implementations of ISO 4 and ISO 5. This is all public. The test plans are out there. But more importantly, the testing tools that were used are also open and available in many cases. And so right behind this pod here is an open and available AMWA NMOS or JTNM tested. It's actually, I think the project on GitHub is called AMWA testing. But anyway, the point is you can actually download this project off of GitHub, compile it, take the test plan, and run your own tests against the equipment to see how it's developing. And we have always, speaking as one of the board members of the JTNM, along with the SMPTE and EBU and BSF, we have always viewed this as a partnership between users and manufacturers. This is not users testing manufacturers' equipment. It's in partnership with the manufacturers, and what we hope is that they would take these tools, take these test plans into their labs so that when they show up at a tested event, or even better yet, at a customer, that they already have a gauge that's public, that other people can use to see what level of functionality they have against the SMPTE standard. So in a nutshell, that's what the tested program is. And I think one way or another, I believe we'll see that continue. And at this IBC, we've talked about how feasible it would be for manufacturers to take the test tool and use it in a particular way, and then upload their results, and on a continuous basis make those results public. We're in initial discussions about that, but whatever we can do to help expose the good work that people are doing on the manufacturer side to make their implementations more compliant and improving, we want to show that. because
Yeah.
there are definitely manufacturers in the industry who are working hard to do the right thing, and they should be rewarded for that.
Yeah.
And users, of course, want to know what's the level of implementation of these specifications.
Okay. Switching gears a little bit, a non-technical question, or at least I think it's not. It actually came from you. You made some comments about how the industry is resource-starved, and there's a lack of people who have the skills and the know-how, and you can tap into. You want to talk a little bit about that? And
That's certainly a challenge for the industry, for the user, for everybody. The main thing is this is a transition between, or convergence between, two different worlds, IT and broadcast. So you rarely find someone who knows everything about all these things. But in many organizations, we have those skills in the building. So the question as a first step is how you tap into those resources and you make sure they collaborate. So for instance, at CBC, we reorganized the teams 2 years ago to embed the IT experts into the broadcast engineering. So it's not anymore two different silos. It's a team, a multidisciplinary team. And that's the only way, because they need to understand the business of broadcast, the IT people, and on the other end, the broadcast engineer need to talk the language of IT to understand that. So that's a first step to kind of be able to move on. And of course, when you hire new talent, young people that are coming out, they will learn that new stack, new role. But I don't believe anymore there will be one broadcast engineer in the plant who knows it all. It has to be multidisciplinary teams. Yeah. And I myself stopped to learn too much about networks, but all my team, they made the class on how to deal with the networking equipment and configuring. But it doesn't make them network experts. It's just they can talk the language with a network expert. So.
And we went through a very similar situation, having started at the infancy of the deployments. We found out that we had 5 different teams working on 5 different projects with 5 different knowledge bases, our own engineering people. And we very much depended upon the manufacturers to help us through that particular case or that particular case. But there was no uniform approach to it. So we, about 2.5 years ago, in partnership with about 11 different vendors eventually, put our own training program together. We put 2 half racks full of equipment. It's 100% 2110 compliant. If it doesn't pass the JDM type tests, it's not in that kit. And we keep adding to this, and we take it around. We've trained probably 250 of our own engineers and another 250 or so industry people, depending upon where the area we were at. SMPTE sponsored in some cases, and it's been very valuable. It's an incremental course as the standards got improved and added onto. That became more and more the course curriculum. So it takes about 2 full days for us to teach a soup to nuts, end-to-end sort of thing. And now we're finding that the real contest here is to how do we begin to teach software-defined networking as it's going to apply to all of our futures. So that's kind of the next agenda, taking the things that are happening with the NMOS, building that up, and demonstrating it and being sure we understand it as well.
Yeah, okay. Did that at all slow down the deployment of IP infrastructure? The lack of skills and
it's a lot longer commissioning process than if you compare a like system with SDI. Now, how long did it take to deploy SDI when it first came out? Yeah, okay. Probably an equal amount. So we, it's somewhere in the middle. We're going to cross the curve here, and it's going to be the ideal number. But right now, it's kind of high, and it's mainly the knowledge base and the continuing developments and add-ons that make things work. I mean, I keep going back to SDI, but we didn't have anything embedded audio-wise in SDI when it first came out. Mm-hmm. And when we started down the high-definition road, we not only changed the data rates of the signals itself, but we added 6 and 8 channels of audio to the system, things like that. We fortunately had that experience as an industry, and we're applying those headaches to making sure that it's easier in an IP environment. So the ability to scale in all different dimensions in IP is going to be far more lucrative and far less complicated as time goes on.
Yeah.
So just a comment about the personnel issue. First of all, what they said. When I visited these 4 broadcasters that I mentioned earlier, they mentioned the cross-disciplinary teams. They mentioned the time that it takes just to learn the technology. But that was one person in particular had an encouraging message that they wanted me to get out there, which is that it is absolutely the case that you need 1 or 2 special people who really conceptually can understand the world of video and what we're looking to achieve with 2110 and networking. Once you have those people, though, who are able to get vendor equipment in and test it and understand why it doesn't work or whatever, after you have that, the approach that these guys have talked about establishing, let's say, fluency, but not necessarily an expert level within these teams, is sufficient to allow them to be able to talk together in language they understand to solve problems for you. And that's really what you need. Everybody doesn't have to be an expert.
Yeah, okay.
Right.
Yeah, I heard some words, identify the network wizard in your team and try to hold on to him and build your team around him. I heard AMWA/NMOS quite a bit. I guess that's the play with words in the title of this session, right? So I want to talk a little bit about AMWNMOS and what's been done there in specifically ISO 4 and ISO 5, right? I think these are the internet specifications everybody's interested in. I think there has been quite a bit of success, right? Everybody seems to rally around AMWNMOS and look at adoption. What can you tell me about the implementation? How ready is AMWNMOS? Is this a full-featured specification, or are there parts missing? And how much of this can we just take and build an infrastructure? Do we need to add any proprietary layers? Or,
I'd like to hear from these guys first before I answer.
Well, we narrowed down the
Well, the one thing I haven't
and
found yet.
we should be frank. We should be frank about
Yeah,
where we're at with that.
but the one thing I haven't found is a catalog that says ISO 4 and ISO 5 buy this here yet. Haven't found that, and I think we're eventually going to get to that. The reason being is that most of the implementation of 04 and 05 are at the broadcast controller or whoever's the prime controller system within your network, and audio being the animal that it is almost in its island to itself compared to all the video and other things that we use in traditional broadcast and production. From the broadcast video portion of it, it's pretty stable. The lion's share of people that are building broadcast controllers are those same folks that built router controllers in SDI world, and they've now got gateways and things that work in that. And they've got their own mechanisms that follow, in most cases, follow all of the specs and the code that's in ISO 4 and 05. But it's got to be, to be successful, it's got to be uniform across every component that's on that network. If you take 100 devices and 95 of them are 04 and 05 compliant, but 5 of them aren't, you got to do something about it because it just destroys the integrity of the whole system. So in many cases, the prime vendor of the control system, pick the 4 or 5 vendors, don't need to mention them, but you get the idea, will have to write a driver or the equivalent type of implementation and work with the particular device manufacturer so that they can talk to each other properly. And I think the structure for this is pretty well established and agreed upon, that there's nothing wrong with the 04 and 05 code level sort of thing. It's just how individual manufacturers are implementing it. And it frankly is a bit of a headache when you're starting the testing and processing procedure of getting things onto a system, but it's really right now it's part of the commissioning process.
So we need to have a good expectation level about these technology. When we talk about ISO 4 and ISO 5, what it's doing, it's quite simple in terms of functionality, but it's necessary. To give an example, when you just want to monitor a signal on a display or on a waveform monitor, or in SDI, you plug a cable and you press on a button and you have an image. In 2110, when you connect it to a network, now you need to assign and manage IP addresses. You need the receiving device, the display. You need to tune it to a number of flows, because if you have an equivalent of SDI, you'll have one video, multiple audio, ancillary data. Each of them have IP address, RTP payload ID, etc., etc. So this just functionality of plugging the blue cable, ISO 4 and ISO 5 is just giving that back. So that the much more time it takes nowadays to build that plan is coming a lot from that simple fact. So ISO 4 and ISO 5, you can see that as just a simple video matrix, video SDI matrix. ISO 8 brings the hybrid router approach, where you can, in addition, shuffle the audio like the embedded audio in an SDI world. So we should not expect more than that from these three interface specification. So yes, we need more than that, and that more than that will come from other NMOS like ISO 7, other proprietary protocols in some case, because you want to have a fine control of some parameters in the device. So we'll have to live also in a multi-protocol environment. And what I like in NMOS, it's really that microservice approach where you pick those simple API for the functionality you need, and then you can combine them with other API for very, very specific control.
Yeah. Brad, do you want to add anything to that? Or
Yeah. So I've been spending quite a bit of time thinking about this, because as I got engaged in the Eurosport project, it was like, okay, I've been working in the AMWA to help make this happen, and now here's the
Now you
rubber
get to see
hits the
reality.
road, right? Now it's time to see if it actually makes any difference or not. And so I think the question of what drives adoption of the NMOS specifications, and specifically 04 and 05, is actually, it really, first of all, it is the users have a problem that is addressed by these things, that is addressed by the having DHCP working on the network and DNS, and combined with ISO 4 and combined with ISO 5. Let me explain what I mean. If you are a manufacturer, you are configuring a narrow number of things in your lab. You probably don't have 500,000 senders and receivers to configure in your lab. And if you need to manually configure it, or if you've gotten one of your software guys to write up a configuration utility that just, you push a button and bam, the stuff is configured in the lab, you're good. If you're a system integrator, you know, as part of your work, you can correct me if you're wrong, because you're sitting right here, but it's part of your work, it's in the plan, whatever, to build that spreadsheet and actually plan out in exquisite detail how this thing is actually going to go together. It's part of the value that system integrators deliver to the users. From a user perspective, once I get a system from Karl, and now I'm speaking with my background as the head of Turner Broadcasting Entertainment Division, Engineering and Operations, which was my old job. Now, you're faced with a very real problem of knowing what equipment do you have, what's live, what's died, where is it, all of that. It was much easier to understand those things in an SDI world than it is to understand in a networked IP world where you've got 15 or 20 things running in a 2-rack unit box. And so when you look at all of the things that this stack of technology from the IT world provides, the 04 and 05, can it all be done in a proprietary way? Yes. Can it all be packaged up by a vendor, maybe a control system or an automation system vendor or broadcast controller vendor, and presented to you in some kind of handy interface? Sure. But I can tell you that within the Turner business, I had no idea what sort of business systems would need to know information about my operation and the coming and going of critical pieces of equipment. And so for me, the importance of something like a centralized ISO4 registry, where when you plug a piece of equipment in and you turn it on, it registers. It has a name. It's not just all by IP address. And it has to check in every now and then. And if it stops checking in, that entry is deleted. And how that simple functionality in ISO4 is accessed by a ubiquitous API that's defined by a specification that's not changing, where you can go in and query and say, is this device alive? Is it dead? What is it capable of doing? And so on. Having that an open service on my network, accessible by any vendor and able to be populated by any vendor, is a very, it's like it's like air, it's like water. It is a fundamental piece of me being able to understand and operate my infrastructure. And I think maybe it's because of my experience at Turner that this is just, it just seems like it's a clear thing that if you operate in a world where you are mechanically assigning every IP address and it's all static to every device and that never changes, and you're not deploying any of the other IT functionality like DNS and DHCP, then you may look at this stuff and say, well, this doesn't do anything for me. I can go in and grab the stuff off of the spreadsheet and type it into this interface and, you know, enable the ports on my switch and everything's good. Well, that's terrific, but if you've got, you know, forget 500,000 potential endpoints at a Eurovision system some, 4 or 5 years from now, if you're a mid-level TV station and you've got 10,000 senders and receivers in your plant, are you going to be manually going in and keeping track of that? No. And some, carefully configured thing at the start is fine, but once that handoff happens and you're running that thing down the road trying to change all 4 tires while the car is going down the road at 60 miles an hour, you got to have some base level interoperable intelligence about your system, and you have to have particular behaviors of new equipment as it's coming into your system that make your system manageable. Otherwise, man, good luck. So I think, as people kind of breathe a sigh of relief and 2110 is working, and then they look at NMOS and they go, well, yeah, maybe interesting or not. And then they go through implementations, and then they're on air, and then they need to change things. I think then there will probably be a growing body of people who go, oh, yeah, now I get it. But being able to refer to something as EVS4 dot, I don't know, ESPN2 dot whatever, rather than saying, 242.28.65.638, just the power of names for our industry is tremendously powerful, but a lot of us are just so used to kind of handcrafting, lovingly configuring every piece. I think a lot of us haven't hit that reality yet, but we will. And the good news is that the IT industry has hit that 20, 30 years ago. The military industrial complex hit it 40 years ago. Those technologies exist. We just have to figure out how to employ those solutions in our space. It's not that hard. Don't make too much very media specific. And Felix said it, keep the functionality we need in small pieces and then pick up little pieces of IT, well-proven best practice IT things that solve that particular problem, and go hit the the next nail on the head with something else.
Yeah. I mean, after all, the promise of IP infrastructure is the flexibility and the agility. I mean, that's what everybody's striving for. So, and if I understand right, that's what this AMWA NMOS gives you, to be flexible in the configuration of your system.
Well, a part of it, you're right, but it only gives a small part. One of the things that we have, a tightrope that we have really had to walk, whether it was in the AMWA or the SMPTE or the VSF, is to establish an interoperable base that's open and then allow the manufacturers to have proprietary things that do more, that are smart, that they're able to make their money off of. I don't have any problem on that. But if I can't tell what equipment I have alive right now in my network in some open way, I'm having some very uncomfortable meetings with the network heads of TNT and Cartoon Network, and I can show you the scars I have on my back from those kinds of meetings, and you know, we just can't be in that position. But in order to, I just want to make this point, that the NMOS stuff, the TR1001 stuff by itself, that won't necessarily do it. It's not like these are magic things. We have to architect these plants in a way that they actually take advantage of this. And, you know, I am as guilty of this, I think, as many people. When nonlinear editing was introduced, the first thing we did was we put in nonlinear editors, and we used them just like we used our old editors, right? Videotape. And to some extent, you know, wanting to handcraft every single multicast IP address there, and I want to be clear, the system integrators are, I don't think, using the wrong tool for the job, because those spreadsheets replicate numbers, they auto-increment, anybody can use them very easily and so on. There's nothing wrong with that as a starting point. But then once you get in the car and you start the engine and you go down the road and you get a call from a head of a network who says, you need to turn left now, you're turning left, you know, and at that point, we need, as an industry, to have transitioned to an overall philosophy of using the power of names, for example, and being sure that my phone in my pocket doesn't always have this hard-coded IP address in it, but instead I can roam from hotspot to hotspot and pull a different IP address, and somebody can still find me because they find me by the host name of that phone. They don't find me by the IP address of that phone, right? Which I'd have to go in and reconfigure that every time I stepped out of this room and went into the hall over there. And right now, from kind of a low-level standpoint, we're kind of at that level of thinking that way, and we really need to be thinking more, for example, how do we take advantage of the power of names? And that's just one piece of it. How do we think more IT, and maybe a little less IP might be kind of a way to sum that up.
Yeah. So it seems AMWNMOS is a good base. There has to be more to be done to develop it. So what we really need is kind of like a rallying cry around AMWNMOS, and to a degree we achieved that already. And then we need to see how we can achieve an industry consensus to adopt AMWS NMOS, right, for this particular control application. You know, do you have any, really quickly, because we are running out of time, any ideas how that can be achieved? Maybe a trick question, I don't know.
Well, demand by the end users that it be in a spec and a demonstrable example that can be shown to the end users of how to use it is a good start.
Yeah.
Yeah.
And we're pretty much down that road.
Exactly. I see at that IBC particularly that we've reached a milestone in terms of agreement around the top of the pyramid, TR1001.
Yeah.
So I think this is done. This is, you know, people can ask that in their product. A vendor are implementing it. Now, to get the full flexibility promises, it's to continue in that direction. Exactly, it's a migration towards, once IP transition is done, it's a migration toward full IT. Software, DevOps, all the things that are existing in that other industry. And just question of adoption and getting a wide understanding of that.
Yeah.
That's it.
Okay, let's see. I'm asked to leave some time for questions from the audience. So let's see if we have any. Any questions to the panelists? Any need for clarification on the different topics? No? Well, maybe we use the last 5 minutes then and talk about the data center. You mentioned microservices, right? Software architecture. There's a move towards software-only applications, so you can actually achieve virtualization, run it in a virtual machine or a container. All these technologies you mentioned, how close are we to that promise of the software-only commodity hardware IP-connected data center? Are you already doing something? Are they already deploying?
Yep.
What are you doing, and how far does that go? Maybe Felix?
It's a question of application. I think there's a big part that can be done. Like, for example, our new master control room rely a lot on software, the playout engine, the multi-viewer. A lot of the kit is software based on our own server that we provide. So then there's the real-time, like low latency sports application. Probably that's the remaining place of a lot of hardware. But we can see it's just question of time, and the number of pieces in the puzzle that need to be purely hardware based is getting low. So it's a question of application. Virtualization, containerization, I think it's a natural extension once the industry moved to software base. We see the benefit of being able to moving around the resource and pooling the servers and sharing the resource across all kind of application. So these are just step iteration over the transition. So question of time, I guess.
Yeah.
I think from a utilization standpoint, IP is going to allow us a lot higher utilization of gear. You may not want to necessarily put this into a VM environment, virtual machine environment, but you might. There are portions of this can run on a VM platform. Portions of the hardware we're typically used to using that's already been ported into software can run on VM in many cases. But it might not be practical for a single small production facility to go that route. If you've got multiple studios and multiple control rooms in a very large tech center with equipment in it where you've typically probably used that, I think some of the studies we did a while back, 3 or 4 years ago, showed about a 27% utilization rate. We're now finding that by employing VM and the techniques used by the IT industry, that number can get up into the 15, 60% level, if not higher. Okay. So there is a positive end to this as we start to move more and more to a software world. Yeah. And we're already seeing that.
Yeah, absolutely. Yeah, I'm on this question of virtualization, especially if people are wanting to understand the business justification for it. Again, I would very much encourage you to go online and look at the presentation that Gordon made, because he spoke directly to this. The operations, the primary operations for Eurosport are going to be in Paris and also in the markets like in Sweden and so on. So that's where the operators will be. And we're talking about a live operation here. The technical guts that make things go are going to be in data centers in London, and they're going to be in Hilversum. And they're not just assigning those frames, let's say a switcher frame or whatever, to a user interface device in a control room over some fiber thing. They're actually looking at breaking up the functionality that's contained within that frame and associating some of it here, some of it there, and so on. Yeah. And so I would just, if people want to see more about a really pretty straightforward justification for it from a business standpoint and what the plans are, again, go see, once these are posted up, go look at Gordon's presentation, because he does a great job of talking about that.
Okay. We're close to the end. Can we fit in another, or any questions From the audience, maybe? Anything you wanted to know from the panelists? Nope? Okay. All right. Thank you very much for attending the panel. I appreciate very much that you came, and thanks to the audience for coming and listening.
Thank you. Thank you, guys. Really did a great job. Appreciate it.
And we're out.
Yeah,
Done.
awesome.